Welcome to Monochemistry. In today's lesson, we're going to look at the concept of spontaneous reactions. Scientists, when they study reactions, want to be able to tell if a particular reaction will occur under a set of conditions, a certain set of conditions. So for instance, at a certain concentration, temperature, and pressure. Now, if you think about it, if you were an industrial chemist and you wanted to make certain products that you were going to sell and you were hired by a company to do that, it would be very beneficial to understand whether or not a reaction will happen under certain conditions. And so scientists, chemists in particular, want to be able to measure whether or not a reaction will occur under certain conditions. And the idea of spontaneous reactions allows us to do that. So the definition of a spontaneous reaction is this: a reaction that occurs under a certain set of conditions. Sounds very simple, but let's go over some examples to see if we can make more sense of this. Let's look at some examples now of some spontaneous processes. Here we have a skier skiing downhill. If you put a skier at the top of a hill facing down the hill, then they will automatically move down the hill. You don't need to alter the conditions. The conditions are set, and therefore this would be a spontaneous process. If you don't like skiing, another example here, more of a physics thing, a ball rolling down an inclined plane. The ball rolling down the inclined plane, again, the work is done by gravity, and it's going to happen under those conditions. No conditions need to be changed to make that happen, and therefore that process is also spontaneous. One thing you should probably notice about this is that, well, in one direction, the reaction or the process is spontaneous. In the other direction, like the skier going up the hill or the ball rolling up the hill, the process would not be spontaneous, as it would require an extra set of conditions. In other words, if the skier skis all the way to the bottom of the hill and stands there at the bottom of the hill, he or she will not therefore move automatically back up the hill like they did going down the hill. Same with the ball. If you get the ball at the bottom of the hill and leave it there, it's not going to roll up the hill. So these are examples of non-spontaneous processes. Spontaneous processes overall tend to be exothermic, which lowers the energy of the system. And most spontaneous reactions do lower the energy of the system. They work towards lowering the energy of the system. However, there are exceptions to that. Let's look at one now. I should say there are exceptions to the exothermic rule. Not all spontaneous processes or reactions are exothermic. Some, like this one I'm about to show you here, are actually endothermic. So an endothermic, i.e. ice melting process, actually is also spontaneous. You can try it yourselves. Take a piece of ice out of the freezer, leave it on the desk, and it will melt. Now that's an endothermic process, but also a spontaneous process. So while the vast majority of spontaneous processes are exothermic, there are some that are endothermic. This leads us to believe, then, that spontaneity cannot be determined by the delta H or the change in enthalpy alone. There is another factor that helps us determine whether or not a reaction is spontaneous. So besides the delta H, we also must take into account the entropy, which we'll talk about in the next lesson. Here's the references for this video, and that in a nutshell is my lesson on spontaneous reactions. Bring your questions to class.